All right, hey guys. So this is the second half of the 4-3 note, starting with the neutralization reaction and salts part. Okay, so excuse me. Neutralization reaction occurs when an acid and a base react. I think we probably all know that at this point. Um, in general, an acid and a base react to form a salt. Okay, so usually, a lot of times we'll say an acid and a base react to form a salt and water. Okay, so acid and a base react to form a salt. Okay, so if you look here, this is now. I kind of wish they would have used a different example, um, because their salt is literally salt, like table salt. But a salt, a salt really is any ionic compound. Um, oh, right here. A salt is any ionic compound whose cation comes from a base and an anion from an acid. Okay, so it could be, um, you know, magnesium fluoride. It doesn't have to be sodium chloride, actual table salt. Okay. The other product, water, is a common non-electrolyte. So um, we've got, they're showing you down here how to do a molecular and a net ionic equation. So they're showing you, you've got a typical example of a neutralization reaction. It's a reaction between an acid and a metal hydroxide. So MgOH2, milk of magnesia, is a suspension. That's a base. Hydrochloric acid is added. So you've got MgOH2, hydrochloric acid. Okay, now it's a suspension. It's not actually aqueous in there. When it's added, the magnesium hydroxide dissolves and a clear solution containing Mg2 plus and Cl minus ions are formed. Okay, to be honest, I don't even really like the word dissolves. Um, in reality, it reacts. Because we know I kind of stressed before that dissolving doesn't necessarily mean it's reacting. Um, so I really don't like that. I really don't like that terminology there. But um, okay, so they show you here. Then the net ionic equation is MgOH2 is still the solid plus 2H plus, and then your products are Mg2 plus because that's not ionized on this side, so it's not a spectator ion, plus 2H2O liquid. We don't break that up. So the spectator ions, if you were writing spectator ion, so the spectator actually is only one. The spectator ion in this would be the CO minus. Okay. All right. Now let's just so let me zoom in a little bit here, a little more. Okay. Just so we're kind of on the same page, let me also show you the net ionic equation for the one that we were given up here as well. Okay, so the net ionic for this neutralization reaction, okay, would be, so the water is liquid, so that is not technically ionized. So what's ionized is going to be the Na plus and the Cl minus, right? So those are going to be our spectator ions. So we've got the Cl is going to come out, so we're just going to be left with the H. So H plus aqueous plus, and then here the sodium is going to be an ion. So we're going to just be left with the, as not a spectator, so OH minus aqueous. And that's going to give us H2O liquid. So that's the net ionic equation. Our spectator ions are Na plus 1 and Cl minus 1. Okay. All right. Let's move on, excuse me, to acid-base reactions with gas formation. So these are essentially specific types of acid-base reactions. They're acid-base reactions that will form gases. It says there are many bases besides hydroxide that react with hydrogen to form a molecular compound. So the reaction of sulfides with acid gives rise to it's really dihydrogen monosulfide gas, or so it looks like, I know this looks like hydrosulfuric acid. But in a gas form, it's actually different. It's dihydrogen monosulfide. So this is the equation, the molecular equation. Here's your net ionic with the spectator ions taken out, which would be the Na and the Cl. Okay, so what's a sulfide? A sulfide is anything, any metal. Write this over here. Sulfide is going to be a metal with sulfur. Okay, so you've got sodium sulfide, right? And it's producing this as a gas. So hold on, let me. Yeah. Okay. So these special cases you just have to memorize. There's no other way, like for what we're doing, to really know it. Just metal sulfide plus an acid gives you H2S. It's kind of like doing the combustion equation where you guys have to memorize that, a combustion equation gives you carbon dioxide and water. Okay. All right, the next one. Carbonates and hydrogen carbonates, or bicarbonates, excuse me, will form CO2 carbon dioxide gas when reacted with an acid. Okay, so will form carbon dioxide. So here's the molecular equation. Here's the carbon dioxide in it. Here's the net ionic with the carbon dioxide. Okay. So a lot of times, as you can see in this one, it's you get a side product. Like the carbon dioxide, in a way, is almost a side product. You get water produced as well as the salt. So this is still an acid-base reaction. Okay. And carbonates and hydrogen carbonates, same type of thing. Is ionic, a metal plus carbonate or bicarbonate. Okay. All right. And the third one, ammonium salts will form NH3 gas, ammonia gas. So ammonium salts will form ammonia gas when treated with a hydroxide. So this is a hydroxide, not an acid. Okay, so you can see here is the ammonia gas. Okay, so what's an ammonium salt? Well, an ammonium salt is going to be ammonium, which is the NH4 plus 1, plus any nonmetal anion. Okay. All right. So those are three sort of specific reactions that produce gas formation, three different ones that you just have to know and be able to go back and know those. All right. Okay. So the last thing with this is I want to do a practice problem from the book. So this is practice exercise. It's on page 134. Okay, it's right here. It's right here. I rewrote it in this, so I'm going to upload this to with your notes as well. Okay. So how to do some of this, like writing the equations and stuff. Okay. Write a balanced molecular equation for the reaction of carbonic acid and potassium hydroxide. All right. So the first thing I would do is most of these, you have to figure out if it's an acid base type of thing. So this says carbonic acid with potassium hydroxide. So we know it's an acid base, right? Then you probably want to do a quick check and make sure that it's not one of your like special ones, like it's not one of these. So, do we have a sulfide with the acid? No. Do we have a carbonate or a hydrogen carbonate? No. Is it an ammonium something with hydroxide? No. So this is none of our special versions of it. So we're just going to do a neutralization reaction. So we're going to write the molecular equation first. Okay. Now, here's the second part. How do we know if it's solid, ionic, that kind of stuff? So what I'm going to do is I'm going to go here and I'm going to look. Okay. So carbonic acid, H2CO3. That is not on my list of strong acids. Okay, so that means it's a weak acid, but it means some of it's still is gonna be aqueous, right? Okay. Let's see. Because here, if we look here, sorry, I guess I should have showed you this first. CO3, hydrogen not an exception, so that means it's gonna be. Wait a minute, that's not right. Oh, alkali metal, hydrogen is in the first row. So hydrogen would be an exception. So that's going to be, carbonic acid is going to be aqueous. So I'm going to try to leave myself enough room here. I'm going to, oh, excuse me. Hopefully that didn't freak anybody out. Okay. Carbonic acid, aqueous, and potassium hydroxide. You can do the same thing. Hydroxide is a solid, but potassium is an alkali metal, so it'll be aqueous. So I'm going to leave a little room for balancing. KOH. All right. Now, we need our products over here. Right, so it's going to be like a double replacement or metathesis reaction. So I'm going to take my hydrogen here, right, H plus, and I'm going to combine it with my hydroxide, OH minus. It's going to give me HOH, or you should by now recognize that as H2O, water. Water is a liquid. Okay, now plus, okay, let's see what's left over. K plus 1, and CO3, carbonate, is a -2. Cross down, we get K2, CO3. Now we have to check and see. It should be aqueous, but let's make sure. CO3 is a solid, but it's combined with potassium, which is an alkali metal, so that will be aqueous. And I just smeared this. Okay. So we just need to balance it. The balancing, let's see. We would need a 2 here and a 2 here. And that should be balanced. Yep. Okay, so that's the balanced molecular equation. Oh, I'm sorry. Out of the thing here. Okay. Now, for part B for this, we need to write the net ionic equation. So we're going to take out the spectator ions, right? So this, just as kind of a reminder, we would just break this up, right? So it'd be, you're talking like the complete ionic. It didn't ask for this, but I'm going to show you just to help people kind of get the in-between if you need it, would be H plus aqueous plus CO3 2 minus aqueous plus K plus aqueous plus OH negative aqueous yields H2O liquid plus K plus aqueous plus CO3 2 negative aqueous. I just squeeze it in there. Okay. So that would be the complete ionic, right? Now, we would pull out spectator ions. So our spectator ions, right, are going to be the ones that are the same on both sides. So here and here. Okay, so our spectator ions would be, and again, it didn't ask for this, but I'm putting it so people kind of get that complete idea. Spectator ions would be CO3 2 negative and potassium, K plus 1. All right, so net ionic equation is this with the spectators pulled out. So the net ionic is going to be H plus aqueous plus OH negative aqueous yields H2O liquid. And that would be our net ionic equation for that one. Okay. All right. Hopefully that helps you guys out for the homework. Let me know if you have any questions.